Let's take a moment to discuss some common statistical terminology. We'll start by defining inferential statistics. Inferential statistics are a set of methods by which we draw conclusions about a large group of individuals, that we call the population, based on information about a subset of that group. It really boils down to one of two activities. The first is estimation. In estimation, we are calculating a guess of the value of something. This could be a quantity, it could be a size or a dollar value. It could be anything that we can measure. One of the canonical examples is associated with how light bulb manufacturers estimate how long a light bulb will last. Now, what they cannot do is take every single light bulb off the line, put it into a socket, and see how long it takes to burn. Because then they will have nothing left to sell. Instead, what they do is they draw a sample of light bulbs, let's say 1 in 100. They put those into sockets and they test them to see how long it takes to burn. Then, based on that information from that subset, from that sample, they'll draw a conclusion about the larger population. That is, how long it will take an average light bulb to burn out, given how long it took each of the light bulbs in the small sample to burn out. The second activity is hypothesis testing. And in hypothesis testing, what we are trying to do is examine the veracity of a claim about the population. Basically, we are trying to say if something is true, if it's false, or if we aren't sure what it is. An example of this would be taking, for instance, new LED bulbs, and we want to know if they last longer or not than incandescent bulbs. So we can test that hypothesis by drawing a sample of LED bulbs and a sample of standard incandescent bulbs, and simply seeing which which group lasts longer on average. Let's define some of the critical vocabulary within inferential statistics. What we're going to use as an example is that we want to understand the height of students here at the Wisconsin School of Business. A population is the set of all the items or individual about which you want to draw a conclusion. It's a large group. In this case, that will be all the potential students you could meet at the Wisconsin School of Business. A sample is a portion of the population selected for analysis. It's the small group. In this case, we may want to try to get a random sample of 15 or 20 students and measure their height in order to draw some conclusion about the height of all the students at the Wisconsin School of Business. Those 15 or 20 students that we analyze would be the sample. A parameter is a numerical measure that describes a characteristic of a population. A parameter could be the average height in centimeter in the student population, for instance. A variable is a characteristic of an item or individual. In this case, the variable of interest is height. And finally, data are the different values associated with that variable. In this case, our data will be comprised of measures of the height of those 15 or 20 students in our sample. Now, I want to take a moment to discuss the two main types of variables that we'll be dealing with in this course. The first type are discrete variables. These assume that you can count the number of possible values. For instance, we could look at the outcome of a coin flip. The outcome of a coin flip is going to be either heads or tails, so it can only take two potential values. Alternatively, we can look at the number of employees that are late to work on a given day. There could be 0 employees late, 1 employee late, 2 employees late, 3 employees late, but you cannot have half of an employee late or 1 3/4 of an employee late. Alternatively, we can look at continuous variables, and these are usually measurable amounts, some things that you can measure with an arbitrary precision. For instance, we could look at how much snow will fall in Madison, Wisconsin this winter. It could be 15 inches, it could be 30 inches, or it could be 15.234 inches. One of the defining characteristics of a continuous variable is that for any two potential values of that variable, there exists some value in between them that is also a potential valid value for that variable. For instance, we could look at how late an employee is to work. An employee could be 1 minute late, or they could be 2 minutes late. And in between those two potential values, there could also be 1.5 minutes late or 1 minute and 45 seconds late. You get the idea. This concludes our brief discussions of the basic terminology that we'll be using throughout this semester, and I'll see you in the next video.